For this example, we're going to use the standard normal model to find the z-score or z-scores that describe the region given by the percentiles. In the standard normal model, remember that our mean is equal to 0 and our standard deviation is equal to 1. If the percentile is the lowest 20% of the data, and the standard normal curve, right in the middle we have z equals 0, and everything to the left of that is the lower 50%. The lower 20% would be approximately this amount. So we want to find the z-score here. Remember, percentiles at a certain z-score, that's the percent that are at that value or below. To find the lowest 20%, we only need to find the z-score and then we have our answer. Because the z-score will tell me where I have 20% at that value or below that value. To determine the z-score, first we need to turn the 20% into a decimal form, so 0.20. Now we need to look this value up in the standard normal table. Since this value is to the left of the mean, we know that the z-value will be negative. In the table, we look for the value that is closest to 0.20, and we come up with 0.2005. We move to the left to find the first two digits of our z-score, then we move up to find the third digit. In this case, our z-score is negative 0.84. We will apply the same technique to the next problem, the lowest 62%. Again, we have the mean in the middle, which is a z-score of 0. Everything to the left of the mean, that's 50% at that value or below. So 62% will be somewhere over here. We want to find the z-value that gives us 62% at or below. Again, we're looking for the lowest 62%. In decimal form, 62% is 0.62. We're going to go back to our standard normal table and look for 0.62. Since this value was to the right of the mean, we know that it's going to be a positive z-value. The closest we get to 0.62 is 0.6217. We go to the right to find the first two digits, 0.3. We go up to find the last digit. Our z-score for this percentile is 0.31. Those are both lowest percents. We want the lowest 20% or the lowest 62%. So in both of these cases, the z-score itself gave us that region. In the next case, where we want the highest 40%, we're looking at a little bit different value. Here I've got my score. My mean is in the middle. The highest 40% is all of this stuff up here. The highest 40% corresponds to the same z-value that will give us the lowest 60%. To find the z-value that corresponds to the highest 40%, we have to, in our table, look up the lowest 60%. Our standard normal table tells us the percentile of that z-score and below. If we want the highest 40%, that's on the other side of the lowest 60%. In our table, we're going to look up 0.60. The value that is closest to 0.60 is given by 0.26. This value tells me the highest 40%. It also tells me the lowest 60%. The next example is similar. In the next example, we want the highest 55%. All of this is the highest 50% plus 5 more over here. We want a z-score that's going to be slightly below the mean, and the highest 55% corresponds to the lowest 45%. In our table, we're going to look up 0.45. Right here we see the value that's closest to 0.45, negative 0.12. So I have a z-score of negative 0.12. In our last circumstance, we want the middle 30%. This one's a little bit trickier. Again, I have my standard normal curve. In this case, I want the middle 30%. That means 15% over here, and 15% over here. In the middle, we know that there's 50% that go to the left and 50% that go to the right. If I want 15% here, that means all of this is the lower 35%, and all of this is the upper 35%. To find the middle 30, first we're going to look at the upper 35%. Upper 35%, that corresponds to the same as the lower 65%. That's all of this. The lower 65%, to find the z-score, we just look for 0.65 in our table. This is the value that's closest to 0.65, so that's 0.39. And now what I want to do is take away the lower 35%. So I went ahead, I found the upper 35. Now I'm going to remove the lower 35. That should leave me with 30% in the middle. The lower 35 corresponds to 0.35 in our percentile table. We can look for this in the standard normal table. 0.3483 is the closest we get to 0.35, and we see it's negative 0.39. This means that for our middle 30%, we are between z equals negative 0.39 and z equals positive 0.39. And that's how we find z-scores that correspond to certain percentiles.